Today we are going to study the conditions for minimum brightness and maximum brightness during interference. Conditions for constructive and destructive interference. Conditions for constructive interference means points of maximum intensity and destructive interference means points of minimum intensity. When we are getting maximum intensity and when we are getting minimum intensity, what is the conditions for constructive and destructive interference pattern? For that, consider the equation we have derived in the last class for the total amplitude square is equal to, when two waves from two coherent sources superimposed each other, then the resultant wave has an amplitude E given by the equation E square is equal to E1 square plus E2 square plus 2E1 E2 cos phi. We have got an equation just like this, and as we know, intensity is equal to E square. Therefore, total intensity of the resultant wave after superimposition I is equal to I1 plus I2 plus 2 root I1 I2 cos phi. This is the equation. Okay, I1 is the intensity of the first wave, I2 is the intensity of the second wave, and phi is the phase difference between these two waves. Now we can see what is the condition for constructive interference. Constructive interference, or it means the point of or condition for maximum brightness. Difference phi is equal to cos phi is equal to 1, phi is equal to 0 or 2n pi. Isn't it? 0 or 2n pi, or when phase is equal to 2n pi, lambda by 2 is equal to 2n pi. For one complete wavelength, total angle turned is 2 pi. Therefore, half of the wavelength lambda by 2, phase is equal to pi. Therefore, for pi we get lambda by 2. Therefore, for 2n pi we get 2n times lambda by 2. 2n times lambda by 2, or it's equal to n lambda. That is, the wavelength should be even multiple of n pi or even multiple of lambda by 2. This is equal to 2n lambda by 2. This should be 2n lambda by 2 or 2n pi. That is, for constructive interference, condition is phase difference between the two waves should be even multiple of n pi or even multiple of n lambda by 2. Even multiple of pi or even multiple of lambda by 2. Or it is equal to 2n pi or 2n lambda by 2, where n is equal to 0, 1, 2, 3, etc. This is the condition for constructive interference or point for maximum interference, maximum brightness or maximum intensity. Next, condition for destructive interference. We can see what is the condition for destructive interference. The same equation we can write E square is equal to E1 square plus E2 square plus 2E1 E2 cos phi, and destructive interference means point of minimum intensity. Intensity is minimum means this third term should be equal to negative. Then we get E square is equal to E1 square minus E2 square. Then it will be minimum. When E1 square is equal to E2 square, we get 0, isn't it? When E1 square is equal to E2 square, when the two waves of the same amplitude, we get E1 square is equal to E2 square. Therefore, when this value is equal to minus 1, we get E square is equal to E1 square minus E2 square is equal to, if E1 and E2 are the same, we get 0, that is minimum brightness or a dark point. Therefore, the condition is 2E1 E2 cos phi should be equal to 0. That is equal to negative 1. That is, this is equal to negative 1 when 2 even now we have to find the condition for destructive interference or points of minimum intensity. Destructive interference, that is when two waves are superimposed, we get certain points with maximum intensity and certain other points with minimum intensity or zero intensity. That is, intensity should be zero or minimum. What is the condition for destructive interference or minimum intensity or zero intensity? That is, for the equation E square is equal to amplitude square is equal to amplitude square of the resultant wave is equal to E1 square plus E2 square plus 2 E1 E2 cos phi. This is the minimum value. Minimum value means this term is negative. This is negative, this is minus. So cos phi should be the maximum negative value is minus 1. Therefore cos phi should be negative 1. That is, E square is equal to E1 square plus E2 square minus 2 E1 E2. That is, I is equal to I1 plus I2 minus 2 root I1 I2. This can be written as E square is equal to E1 minus E2 whole square. And obviously E1 square plus E2 square is the total intensity. There is an additional negative term, therefore it is less than the total. That's a clear one. Less than the total value, and intensity is equal to I1 plus I2 minus 2 root I1 I2. If even intensity of the first is equal to intensity of the second, then we get, or E1 is equal to E2. Amplitude of the first wave is equal to amplitude of the second wave, or if two waves of same amplitude superimpose each other, then E square is equal to E1 E1 E2 therefore E square is equal to E1 square plus E1 square minus 2 E1 E2 minus 2 E1 E1 minus 2 E1 square. That is equal to E1 square plus E1 square 2 E1 square minus 2 E1 E1 2 E1 square, that is equal to 0. That is, intensity is 0. If they are of same amplitude, then total intensity is equal to 0. Same amplitude അല്ലെങ്കിൽ ചെറിയൊരു intensity, minimum intensity ഉണ്ടാവും. So what is the condition? Cos phi is equal to minus 1, and when cos phi we get cos phi is equal to minus 1, for phi is equal to 2n plus 1 lambda by 2, or it is equal to n times pi. N is equal to 1, 3, 5, etc. Odd multiples. N is equal to pi, 3 pi, 5 pi, 6, 7 pi, here values we get phi is equal to negative 1. Or corresponding to that, we get in terms of wavelength, we get 2n plus 1 lambda by 2. That is the condition for destructive interference. Then we get the wave in the form, waveform. Minimum 0 intensity and phase angle and wavelength. When angle is equal to 0, here pi, 2 pi, 3 pi, 4 pi, 5 pi, etc. Here minus pi, minus 2 pi, etc. For the wavelength, phase is equal to wavelength phase angle. Pi is equal to 0, we know that we get constructive interference or maximum reading. When for odd multiple of pi we get minimum intensity, therefore it is minimum. For even multiple of lambda we get maximum intensity. For odd we get minimum, for in the same manner we get. This is the corresponding expression for interference. We get the interference pattern in phase get the intensity distribution maximum minimum. In the minimum 0 we get here touch distribution. ഇനി ഒരു കാര്യം കൂടി ഞാൻ പറയാം ഇന്ന്. കണ്ടീഷൻസ് ഫോർ സസ്റ്റെയിൻഡ് ഇന്റർഫറൻസ്. What are the conditions for sustained interference pattern? Sustained means well defined. Well defined ആയിട്ടുള്ള ക്ലിയർ ആയിട്ടുള്ള ഇന്റർഫറൻസ് മാക്സിമം മിനിമം കിട്ടാൻ വേണ്ടിയുള്ള കണ്ടീഷൻസ് എന്തൊക്കെയാണ്? There are certain conditions നമ്മൾ ചിലതൊക്കെ പറഞ്ഞിട്ടുണ്ട്. First one, the two sources should be coherent. The two sources used to produce interference pattern should be coherent, and light waves coming from these two sources should be monochromatic. The second condition should be monochromatic light waves coming from the two coherent sources. Then the light waves coming out from the coherent sources, obviously there should be same wavelength and same frequency. There should be same wavelength and same frequency, same phase or constant phase difference. Constant phase difference. This is the coherent source condition. Same wavelength, same frequency, same phase or constant phase difference is another condition. And another one, the two monochromatic sources, the sources of light, the two coherent sources should be very close to each other. Very close to each other. Another condition. And another one, they should be of equal amplitudes. The two waves should be of equal amplitudes. Equal amplitudes ഇല്ലെങ്കിൽ നമുക്ക് കിട്ടുന്ന മിനിമം എന്ന് പറയുന്നത് മിനിമം 0 ആയിരിക്കില്ല, somewhat higher than 0 ആയിരിക്കും. Therefore there should be നമുക്ക് സസ്റ്റെയിൻഡ് ആയിട്ടുള്ള ഇന്റർഫറൻസ് പാറ്റേൺ കിട്ടണമെങ്കിൽ amplitudes of the two waves should be of same value, equal amplitudes, close to each other ആയിരിക്കണം. വേറൊന്ന് sixth one, the sources should be very narrow. Sources broad ആയിട്ടുള്ള സോഴ്സ് ആണെങ്കിൽ നമുക്ക് ഇന്റർഫറൻസ് കൃത്യമായിട്ട് കിട്ടില്ല. Sources should be very narrow. And another one, ഇനി നമ്മൾ ഉപയോഗിക്കുന്ന രണ്ട് സോഴ്സസിനുള്ള ലൈറ്റ് രണ്ട് കൊഹറന്റ് സോഴ്സസ് ആണ് നമ്മൾ പറയുന്നത്. കൊഹറന്റ് സോഴ്സസ് ലൈറ്റ്. If these two lights coming from the coherent sources are polarized, polarization നിങ്ങൾ പഠിക്കും. ഇത് കഴിഞ്ഞിട്ട് ഇന്റർഫറൻസും ഡൈഫ്രാക്ഷൻ കഴിഞ്ഞിട്ടാണ് പോളറൈസേഷൻ വരിക. If the lights are polarized lights വേറെ പ്രത്യേകത അതൊരു ഡയറക്ഷനിൽ മാത്രം വൈബ്രേറ്റ് ചെയ്യും. അങ്ങനെയുള്ള ലൈറ്റ് ആണ് വരുന്നതെങ്കിൽ they should be of same type. If they are polarized lights, if these two sources we are using are sources of polarized light, then they should be of same type. അതായത് ഒരേ ടൈപ്പ്, പലതരത്തിലുള്ള പോളറൈസേഷൻ ഉണ്ട്. There are different types of polarization, and these two light waves should be of the same type of polarized light. ഇത്രയൊക്കെ conditions ആണ് conditions for sustained interference pattern. Okay, thank you. I am stopping here. We can meet in the next class. Okay.